Welcome to Fantastic Vision. Please subscribe us before you watch today's video. In recent years, with the continuous advancement of science and technology, chip technology has become fiercely competitive on a global scale. The traditional way of manufacturing chips, with photolithography machines, has encountered great challenges in facing increasingly smaller chip manufacturing processes. However, China's scientific and technological community is developing new manufacturing processes and technical means, and is expected to achieve manufacturing breakthroughs in 5 nanometer, 7 nanometer, and 14 nanometer chips while surpassing traditional photolithography machines. Although China's cutting-edge processes such as 14 nanometers, 7 nanometers, and 5 nanometers are unable to be mass-produced, it severely restricts the supply of EUV lithography. Fortunately, recent news shows that China has overcome the difficulties in the manufacturing process. Perhaps China will soon be able to fully localize the high-end manufacturing process. One is the SAQP, based on the 7 nanometers process of deep ultraviolet lithography independently developed by domestic semiconductor companies. It has been applied in the 10 nanometers process and has the possibility of the 7 nanometers process. SAQP is a multiple exposure method that uses the existing deep ultraviolet lithography process. After multiple exposures, it can reach the 7 nanometers process. This technology has long been confirmed by TSMC. TSMC continues to maintain its original process standards in the 7 nanometers process, and uses deep ultraviolet lithography to achieve mass production of the 7 nanometers process. After completing the first generation of the 7 nanometers process, it then uses the EUV lithography process to develop the second generation of the 7 nanometers process. EUV process. Based on China's current advanced process level, and the fact that domestic semiconductor manufacturers have begun to adopt the 10 nanometers process, China is expected to speed up the large-scale production of the 7 nanometers process. However, there are also certain flaws, that is, the price of the 7 nanometers process is relatively high. However, these are not problems. China people pay more attention to the feasibility of the 7 nanometers process. The second is to break through the technical bottleneck of China's semiconductor manufacturing technology and mass-produce domestic lithography equipment. This is the most fundamental method, and China has also made great progress in this field. Recently, Harbin University of Science and Technology announced that it has developed high-speed, ultra-high-precision laser interference technology, also won the first electronic optical equipment of China's Golden Sway Award, breaking through the technical bottleneck of China's high-end optical equipment in one fell swoop. The Golden Sway Award, in China's electronic product rankings, provides strong support for China's development in the field of high-end photolithography. As the current main chip manufacturing process, photolithography machines have gradually been unable to meet the increasing chip manufacturing requirements during process iterations. China has made a lot of exciting progress in R&D and application in this area. For example, Using self-assembly technology and nano-imprint technology, precise manufacturing of chips can be achieved. These new manufacturing process methods can not only break through the constraints of traditional photolithography machines, but also achieve higher manufacturing precision and efficiency. With the support of new manufacturing processes that surpass photolithography machines, China is expected to make a breakthrough in the manufacturing of 5-nanometer chips. The key to 5-nanometer chip manufacturing lies in the size of processor transistors. Through the application of new materials and new processes, smaller-sized transistor manufacturing can be achieved. This will provide the basis for chip performance improvement and power consumption reduction, thereby meeting people's growing demand for chip performance. Photolithography is an important bottleneck in the development of high-end processes in China. Currently, China has conquered 7 major processes. The etching machine and photoresist have reached 5 nanometers. The packaging of wafers can reach 4 nanometers. Other processes can also reach 14 nanometers. Photolithography can even reach 28 nanometers. The difficulty with lithography machines is that they involve a very long industrial chain. It is said that ASML has more than 100,000 EUV lithography machines, jointly manufactured by more than 5,000 companies around the world. This shows that its manufacturing process is difficult, and that is why China's development has encountered huge obstacles. However, China's attainments in lithography technology are still very high. China is the only country in the world that has relatively complete lithography machines. This is why everyone in China knows that the shortage of lithography machines and materials has made China it had to rebuild its own production line. Through the unremitting efforts of the Chinese government, the country has gradually overcome technical problems such as dual workstations, laser light sources, and objective lens systems. Harbin Institute of Engineering announced that this high-precision manufacturing process can already assemble all parts with high precision, thereby reaching the final stage of optical technology. It is expected that domestic high-end lithography equipment will be mass-produced soon. The development of China's chips has actually laid a solid foundation as early as China entered the manufacturing field. Therefore, China has been able to make significant progress in the fields of more advanced photonic chips and quantum chips, establishing the world's first photonic chip and quantum chip production lines, achieve breakthroughs in higher-level chip technology, and promote the continuous development of silicon chips. The number of high-tech talents in China ranks first in the world. Since 2010, China has ranked first among the world's manufacturing powers. It pays special attention to scientific and technological research. China's investment in scientific research has continued to increase for 11 years. China's patents, the number of applications, ranks first in the world. Under such good conditions, China can advance hand in hand in multiple fields, and the problem of photolithography will surely be solved.